Weather is not just something that happens here on Earth. It also occurs in the empty vacuum of space and is often a lot more intense. Solar wind, among other solar events such as massive explosions called coronal mass ejections, can often have a massive influence on our planet. A solar storm is a burst of energy from the sun's surface that can result in power outages, reduced system functionality, and more. These storms have been known to affect satellites, space stations, and astronauts, aviation systems like GPS or our modern-day planes with their navigational instruments, as well as power grids, to name just a few. An example was when Canada had an electrical grid collapse in 1989 due to increased activity on the sun's surface, which resulted in millions of dollars in damage and revenue lost, directly affecting 6 million people. As time goes on, we are becoming increasingly more dependent on technology, which puts us at a greater risk to these types of events. A large solar storm today could potentially cause billions, if not trillions, in damage. The sun's magnetic field goes through a cycle called the solar cycle. Approximately every 11 years, the sun's north and south pole flips completely. The middle of the solar cycle is the most active, also known as solar maximum. Then when the poles flip, it's known as solar minimum, as there is the least activity with the new cycle. The sun has just entered another solar cycle in 2020, meaning in the year 2025 we should be in the next solar maximum. A recent near miss occurred in the summer of 2012 when a giant solar storm hurled a radiation-packed blob towards Earth at more than 9 million kilometers per hour. Had it come just 1 week earlier, we would have been hit with devastating consequences and an estimated $20 trillion in damage. This solar storm was as big as the 1859 Carrington event. The only difference now is that we are far more dependent on technology, and luckily for us, it missed. Scientists learned about this only after the fact, since they had designed satellites to watch for these kinds of space weather events and protect us from their effects when necessary. If that's not a warning, I don't know what is. But how long before a solar storm of that size hits us and causes devastating damage? The answer is, we don't know. It could be tomorrow, or it might not happen for 100 years, but one thing that scientists do agree on, we are long overdue. It's not just solar storms we need to worry about, there is also radiation. There are two types in which spacefarers should be most concerned about: galactic cosmic rays, so high energy particles from other galaxies, and solar particle events, which are high energy particles emitted by our sun. Powerful solar radiation from these storms has the potential to damage electronic circuits and satellites and harm astronauts on board as they travel through space. Not only is this harmful to others outside of our planet, it also affects passengers flying over the North Pole because they'll receive an increased level of radiation during their flight. The more we go into space, the stronger our current weather prediction abilities need to be. To create a greater picture of solar activity and mitigate its effects around the solar system, better modeling and investigation of evolving solar features is necessary. Not only for space exploration, but also for protecting us here on Earth from the bigger storms that would bypass the protection of our atmosphere. So how can we protect ourselves from these solar flares? The Earth's atmosphere protects us from the sun's fire hose of energy, which would otherwise scorch our planet with its intense heat and radiation. Unfortunately, this isn't always a strong enough defense against solar storms that can overpower Earth, as we see in geomagnetic storms. These storms can often interact with particles overlying Earth, which cause an electric charge called auroras at either pole due to changes in atmospheric ionization, also known as the Northern Lights, which are a beautiful event to witness. However, when a coronal mass ejection arrives, it creates currents in the atmosphere and on the ground. That's when power grids start to feel the heat. They have trouble with voltage stability due to the large-scale changes in Earth's magnetic field caused by the solar winds. The Foundation for Resilient Societies says that protecting large power transformers costs about $350,000 per circuit. Safeguarding the grid against solar storms and EMPs would cost between $10 billion to $30 billion according to them. They cite high voltage direct current technologies as a possible solution which can withstand all but an intense coronal mass ejection event or nuclear electromagnetic pulse attack on Earth's magnetic field. Another possible solution utilities are working on is building capacitor banks which work like batteries to absorb and dissipate excess energy, or installing electricity dampening devices called Faraday cages, which act similarly to force fields in order to protect critical pieces from currents. Either way, we need to come up with a viable solution for these storms, as the potential damage would be catastrophic. Perhaps NASA's Parker Solar Probe, which launched recently in 2018, can help answer some of these important questions we have about the sun's solar winds. The potential damage of these incredible forces is catastrophic to say the least, and the sooner we come up with a solution to counter these storms, or at least predict them, the better. Are you worried about solar storms? Let me know in the comments below. A lot of time and research goes into these videos every week. If you enjoy watching, why not hit that subscribe button, or just check out some of the other videos. Thanks for watching.